of the first and the consequent of the second. Okay, that's hypothetical syllogism. Okay, disjunctive syllogism. This is only for ors. Okay, this is a box or circle. So if you have two suspects, Joe or Frank, and you want to prove that Frank did it, you need to show that what? Joe didn't do it, right? You need the opposite of the first one. So disjunctive syllogism works like this. You have a disjunction, you have the opposite of the first thing, you get the second disjunct. That's disjunctive syllogism, okay? And it's the opposite of. So look, suppose I have not P or X, and I have P, what do I get?
X.
Yes. Everybody see that? Okay. And these could be big old expressions. So long as I have the opposite of the first disjunct, I can do it. Now, you might want to get the first disjunct. Well, suppose that you have this, you can convert it by com, which we haven't really talked about yet, to this or this, and you want this, so then you go find a non-circle. Everybody understand that? So you can get either one of these, but you have to do com moves to be technically legal, okay, if you want the other disjunct. So you have a disjunction, you have the opposite of the first disjunct, you get the second disjunct. That is disjunctive syllogism, and it's only for or statements. Okay. Okay. Simple dilemma. We have box or circle. If we have box, we get a triangle. If we have circle, then we get a triangle. So if we have a box, we get a triangle. If we have a circle, we get a triangle. We have either the box or the circle. What are we going to get?
Triangle.
Yep, every day of the week. This is a simple dilemma. And that's what I've said, when you see what you need, suppose we need a triangle, and you see that it's in the consequent of a conditional twice, chances are that simple dilemma will let you get what you need, which means you need to go look for one of those. Okay? And notice there are no negation signs here, but there could be, just so long as whatever you have is the substitution instances of these things. So look, this could be not P or Q, not P then X, Q then X. What are we getting? Say X. Okay. All right. So this is simple dilemma. Okay. Now this next one is very much like simple dilemma, except for one difference. Box or circle, box, then we get a triangle. But if we have a circle, we get something different. Let's say a diamond. Okay. So what are we going to get from these three facts? Well, if we have this, we get this. If we have that, we have. If we have that, we get this. So we're either getting this or that. We're getting this or that. And this is constructive dilemma. Oftentimes I'll call it complex dilemma because it reminds me of simple dilemma, but a little more complex. Okay? And everything I said about, these could be simple statements or negated statements or complex statements is true here. It's true for all of these things. Okay? And remember, all you need is these three parts. They don't have to be in that order in the premises, and you can claim this one. Okay? That's constructive dilemma. Okay, simplification. Box and circle, from that, you can say box. Okay? Simplification only works for conjunctions. All the time I'll see stuff like this, box or circle, box by simplification, or box then circle, box by simplification. That's all illegal. Simplification is only for conjunctions. Okay, when you look on those sheets, don't pay attention to just the patterns of the antecedents, consequences, or whatnot. You have to look at the operator, okay? If it's not the same operator, you can't use it, okay? So, and notice that on simplification, I get the first conjunct. So I cannot do this, box and circle, therefore circle by simplification. Yes, that is logically valid, but no, it doesn't follow our rules. Does everybody understand that? Our rule says if you have a conjunction, you get the first conjunct, okay? So if you wanted to get the circle, you should be able to, but well, this is what you would have to do. You'd have to say, well, since I have box and circle, that means I have circle and box, and then you could simplify to circle, okay? So, and this step is calm. I guess I should do calm. And people skip that all the time, okay? And so, simplification, conjunction, if you have a box and you have a circle, you can put those together as box and circle. This is conjunction. When you're making it, and it's only a conjunction, it's only, right? You can't take two of those things and say, oh, you can't go from I have this and I have this to box, then circle. No, it doesn't follow, right? Or box by this rule of conjunction. You can't say that either, or if and only if, or whatnot. Does everybody understand that? This rule of conjunction is only for making conjunctions, okay? And by the way, from this, you can do this. You can also go to that, okay? All right, so that's conjunction. And then we have one more on the rules of inference, and that is addition. If I have a box, I can say box or anything I want, and this is addition, okay? I can't say box, then anything I want, right? Or box and anything I want. It's only what? Ors. It's restricted to ors, okay? Okay, and what I add on here could be a simple statement constant, it could be a negated statement constant, or it could be a complex statement, negated or otherwise, right? If I have X, I could say X or not A and B. I can add whatever I want. Why? Because remember, these rules are supposed to say this is a valid inference, which means if the premises are true, the conclusion is true. Well, if X is true, then X or anything is true, because true or anything is true. That's why we can add whatever we want, okay? So that's addition. Okay, so those are all the rules of inference. So now I'm going to start the rules of replacement. So these are the rules of replacement. So these are equivalences, which means wherever you have an instance of the one, you may change it to the other, okay? And it could be the case that you're changing the entire line, but you can also change part of a line, like the antecedent of a conditional, using the rule of replacement, so long as you leave everything else the same. Does everybody understand that? Okay. So, De Morgan's is the first one we need to talk about, De Morgan's. We've been talking about this a ton. And so if I have a negated conjunction, I can convert that to this. I push the negation sign through. I get the opposite of whatever the first conjunct is. So I get the opposite of the box. And changes to or, and then I get the opposite of the second conjunct. Okay, that's how it works. Okay, so let's suppose I have not P and Q. What would I get? I would get the opposite of P, so not P, and changes to or, and Q changes to not Q. Okay, and if I had not P and Q, push the negation through, I get the opposite of not P, which would be what? P, and changes to or, and I get the opposite of Q, which would be not Q, right? So remember, this notation means opposite of, okay? Now, you can do De Morgan's on negated conjunctions. You can also do De Morgan's on negated disjunctions, okay? And the pattern is the same. You get the opposite of the first thing, so not, or the opposite of box, or changes to and. So in De Morgan's, ors change to ands and ands change to ors. And then I get the opposite of the second thing. Okay, so I can push the negation through, and by the way, of course, I can go from this back to that, right? And also from this back to that, okay? Okay, that's De Morgan's, okay? Now this is a rule that we're talking about quite a bit because people have been cheating. And this applies only to conjunctions and disjunctions, okay? Suppose I have a box and circle. Well, guess what? I can replace that with circle and box, or vice versa.